Okay, so what we have here is a pulley problem, an application of Newton's second law sa Atwood's machine. So we have here M1 and M2, and we are asked to solve for F net, total mass empty, acceleration, and then the tension existing in the wire. With the given setup, let us solve for weight 1 equals to M1 times G. G corresponds to acceleration due to gravity that has a value of 9.8 meter per second squared. Alright, so let's give values for our mass 1 and our mass 2. Let us assume that our mass 1 is equals to, say, 10 kilograms. And then for our mass 2, let's say that it is 15 kilograms. Alright, to determine weight 1, we just plug in the values. For M1, it's 10, and for G, it's 9.8 meter per second squared. Times 9.8 meter per second squared. Okay, so that will give us 10 times 9.8, it's 98 Newton. So take note that the unit for weight is Newton because weight is also a force. Alright, so that is our weight number 1. Okay, what about for weight number 2? Let's try to solve it. So for weight 2, we have W2 is equals to M2 times G. So we just plug in the values. For M2, we have 15 kilograms times 9.8 meter per second squared, and that will give us a value of, so this is a multiplication, 15 times 9.8, that will give us 147 newtons. Alright, so now we have our W1 and our W2. We can now find the F net of the problem. Okay, so number 1, F net, we just simply subtract the smaller weight to the bigger weight, no? So in this case, we will subtract W1 from W2. Alright, so let me write it down. F net is equals to W2, which is bigger in value, 147, minus the smaller value, weight 1, which is 96 Newton. Or rather 98 Newton. So that will give us 49 newtons. So this is our F net. Let's box it. Okay, now for number 2, for the total mass, we just simply add the two masses together, you know. So number 2, MT is equals to M1 plus M2. So our M1 is 10 kilograms, our M2 is 15 kilograms, and that will give us 25 kilograms. So this is our mass total, or the total mass, which we will be used for determining the acceleration later. Okay, so that's for number 3 is the acceleration. Now keep in mind that when we solve for the acceleration, we're going to use the F net and the total mass, because you have to remember that the system is connected by the string. So we can use Newton's second law, F equals ma. Our F net, okay, 49 Newton. Our total mass is 25 Newton multiplied by acceleration. So we do not want 25 kilograms beside acceleration, so we need to divide this side of the equation by 25 kilograms. Okay, we need to do it also on the left side of the equation, 25 kilogram. So we cancel the 25 near A. So what is left now is A is equals to 49 Newton divided by 45 kilograms. So that will give us, so since we're looking for acceleration, the unit is meter per second squared. So 49 divided by 25, that will give us 1.96 meter per second squared. So this is our acceleration. Okay, let's box it. There. So now let's try to solve for the tension. And that's number 4. So there are two ways we can solve this. The formula is T equals to W minus or plus F. Okay. Okay, so again, we can divide this pulley system, no, into two, or this pulley problem into two systems. We can have the system 1, this one, and we can have the system 2. So let me just choose or pick another color for system 2. So this is our system number 2. Alright, so for this problem, let's try to use system number 2. Okay, using mass 2. And we know that mass 2 is going down since it is heavier. So if it's going down, we will use subtraction or minus. Okay. For M1, we know that it is going up. No? So for the masses that going up, we will use addition. Okay, we just simply add the force in it. Okay, so let's have the tension using system number 2. Okay, so TW or T equals W minus F. Why minus? Because the mass 2 is going down. Okay, so let's just plug in the value. So W2, and of course F2. So W2 is 147 Newton. Let me just write it here. Minus F2. So we do not have F2 yet. So we need to solve F2. Alright, so let me just arrange this. Okay, solving for F2 equals to M2 times acceleration. So our M2 is 15 kilogram times acceleration 1.96 meter per second squared, and that will give us 15 times 1.96. Okay, and that gives us 29.4 newtons. Okay, so 29.4 newtons to be subtracted to 147 Newton, and that will give us the tension is, let me pull up my calculator. 147 minus 29.4. Alright, that gives us 117.6 Newton. So this is our tension, or computed tension. Remember, we only computed the tension using system 2, no? So we can also determine the tension using system 1. Alright, so let's try it. So instead of subtraction, we will use addition this time. So that's going to be tension is equals to W1 plus F1. So let me just fix this. Okay, so this is our, again, system 2. Now we will use system 1. So let me repeat that. So that will be T equals to W1 minus F, or rather plus F2. Okay, so we've already used the subtraction, so now we will use the addition. So W1 is 98 newtons plus F1. So since we do not have F1, let's solve it. M1 times A, our M1 is 10 kilogram multiplied by 1.96, and then this will give us 19.6 newtons. Okay, so don't forget the unit. So we'll just add this to our weight 1. So it becomes 98 Newton plus 19.6 Newton, and that will give us 117.6 Newton. Okay, so if the computed value for system 2 and system 1 are the same, therefore our tension is correct. So that's how you get the tension for this pulley problem.